Hey everyone. So I've posted a couple articles about ways to troubleshoot concurrency problems. Now I want to demo what that looks like in action. So what I'm going to do, I'm going to take a common concurrency problem. In this case, I'm going to tackle the dreaded deadlock, and I'm going to investigate the problem, and I want to show you the actions that I take so you can see what I'm doing. And I'll be using my concurrency generator to help me test a solution that I come up with. Ready? Here we go. So now what I'm going to do is I'm going to be troubleshooting a deadlock or a set of deadlocks. And just to set up the scenario a bit, I would normally attack this problem if I'm handed a set of deadlocks to troubleshoot. In this case, let's look in here. What I have is a set of deadlock graphs. Each graph is a file which contains a whole bunch of information about instance of a deadlock that SQL Server detected and dealt with. Let's take a look at one. I'm going to open it up in SQL Server Management Studio, and first thing you notice is that there's 4 ovals and 4 rectangles. The ovals are processes and the rectangles are resources. The ovals are fighting over access to the resources, and they happen to be fighting in a circle so that they get deadlocked. No one can do anything. Everyone's waiting on everybody else. And you can actually see that SQL Server detected and chose this process as the deadlock victim. Alright, now that's 4 processes. Because I happen to know that each one of these deadlock graphs indicates the same problem that I'm trying to troubleshoot, I'm going to pick a deadlock graph that's actually smaller. I'm going to pick graph 112 and open it. Yeah, I can deal with this. This one only has 2 processes fighting over 2 resources. This process owns an exclusive lock on this key lock. I like to think of key locks as a row, just mentally. And this one owns an exclusive lock on this row up here. But they're both waiting for the other guy to release that so that they can get a shared lock on it. Now, shared locks and exclusive locks are mutually exclusive. They are incompatible, and so that's why we wait. So let's look at the specifics. This resource is a key lock, which means it's a row in the table my people. And that table is in the schema person, which is in the database AdventureWorks. In particular, it's got an exclusive lock on a row in an index called pk_person my people. Because of the naming convention, I happen to know this is the primary key. And it looks like this resource is the same kind of row, or the same kind of key lock. And the processes, what do we know about this? Not much. It's running a store procedure inside database 9, which is AdventureWorks, and the object ID of the process is given there. Don't know much else about that yet. I do know that this process was running the same procedure. Great. So I think now it's time to look a little bit closer at this particular deadlock. So the way I dig deeper into these deadlock graphs is by opening up these files in an XML editor. It turns out that these deadlock graphs are simply defined as an XML. So you can open this up in Notepad or your favorite XML editor. I'm going to use Visual Studio because that's what I like to use. There it is. Right away, you notice that it's got the same information. There's the processes, but it's got a lot more details. So before we knew that this procedure, now we know that not only is that procedure named AdventureWorks DBO as person my people delete, but that it was running that query when it deadlocked. And we also know that the other procedure was running the same thing as person my people delete. I want to find out more about this procedure because it was the thing that was deadlocking. So I'm going to copy. That's in the clipboard now. I'm going to use Management Studio to be able to do that. So sp help text and results to text F5. There's the definition. All right, because we're connected to AdventureWorks. It's a very simple statement. Delete person my people and where business entity ID equals business entity ID. Now it's very unusual for a procedure this small to participate in a deadlock, especially when person my people. Let's look at this. Results to grid, Alt F1. Okay, there's the indexes. Especially this table has a clustered unique index on business entity ID. So I know that something else is going on here. Maybe there's a trigger, or maybe there's an indexed view on person.mypeople that needs to be updated every time there's a modification, or maybe there's a foreign key that needs to be enforced. Something has to explain why after a modification it continues to want to read other different rows in the same table. In order to find out more, I'm actually going to look at the execution plan. So let's copy, paste, and let's see, I'm going to highlight that and display estimated execution plan. All right, there we go. This gives me a lot more information. Here are the things I notice. There's a missing index warning, of course. Looks like my unindexed foreign key theory is looking better, because look, there's the delete. It goes into the table spool, the rows that are about to be deleted. It comes out there, and it looks for each row. It makes sure that it scans the table in order to find, let's see, mentor ID. It's looking for mentor ID. It wants to assert that there are no rows where mentor ID is pointing to business entity. So my guess is, looking at the missing index details, sure enough, it wants an index on mentor ID. It's pretty clear to me that this table needs to enforce results to grid, Alt F1. It needs to enforce this foreign key, FK my people, where mentor ID references business entity ID. Right, so it's a foreign key to itself, and it needs to scan the whole table in order to enforce that foreign key. That's looking like my root cause, and I believe that adding the missing index that's suggested here will help solve my deadlock problem. But how do we know for sure? That's next. Okay, where are we? We looked a little at this procedure as person my people delete, and in particular this query, this delete statement that was giving us some deadlock problems, and we have a pretty good idea of its root cause. Basically, this delete statement needed to scan person.mypeople in order to enforce a foreign key, a self-referencing foreign key, and it's that reason that it's participating in deadlocks. So my theory is that if we have an index on mentor ID as suggested by these missing index details, if we create that index, that it will not only speed up the query, but it'll help concurrency and avoid deadlocks. And that's the solution that I'm recommending. But before I can say that I nailed this problem, I need to reproduce it and then see that the fix solves the problem. And I can do that using my load generator that I've been talking about in my blog lately. First, I want to define a sDoSomething in tempdb. All right, let's use tempdb, and I'm going to just modify example from my blog. We're going to alter a procedure dbo.doSomething. Now I only care about an integer parameter, right? Because the store procedure I care about only has the one parameter. It's in, let's change it as, there. That looks pretty good. But I actually want to modify that value. In order to do that, let's take a look at person.myPeople. I'm going to take a look at some of the range of values. Max business entity ID and max mentor ID. Let's see how that does. Okay, that's interesting. So the largest mentor ID is 1038. So I want my integer value to be at least that. And the range is that. So whatever, that range. Okay. And just to avoid off by one errors, I'm going to call that 9. And I'm going to shrink this range a bit. All right. So that sounds good. Let's create it. Oh, it doesn't exist yet. There we go. That sounds good. Now that it's defined, now that sDoSomething is defined, I want to call it a lot of times concurrently. This is done with the utility that I have. This is the concurrency launcher, and you can look at the definition of it, which is in my blog. And after it's compiled, I'm going to launch it. So we wait a little while, and oh look, there's a deadlock. And as things start blocking up, I expect a few more blocking, more deadlocks, more. Yeah, there we go. All right, I would say that we've reproduced the problem. I'm going to cancel that. Let's launch it again just to make sure. Deadlock, 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 deadlock. Ah, very good. Isn't that great? I can reproduce this problem at will. All right, let's see if my theory is sound. My theory is that if I create this index, call it my index, name it something better later. Ta-da! My theory is that once that's created, I should no longer see any concurrency problems. Let's launch it again. I'm hoping to see nothing. I'm hoping to see nothing. Yeah, it's looking pretty good. Wow, it completed. So it completed, which tells me that it has executed 500,000 procedures, all concurrently, 50 at a time, without a single deadlock. That is encouraging news, and now I would feel comfortable recommending this index as a solution to the set of deadlocks that I was troubleshooting. So, in conclusion, that's an example of how I use my utility. I find it useful enough that I've added a shortcut to my Windows taskbar and that gives me one-click concurrent database activity. It helps me look closer at issues where processes suffer from unlucky timing or other problems that are hard to reproduce because of fussy concurrency conditions. I hope you found this useful. Cheers.